Welcome to the Forest Analytics Landing Podcast. I'm your host, Matt Russell. In this podcast, we'll talk about how data and analytics are transforming the forest products industry. We'll share how a research-based approach to analytics can empower your forestry organization to make better decisions with your data. Hi, everyone. Welcome to the podcast today. Today, I want to talk about what we should be teaching more of to students in quantitative forestry. And so I define quantitative forestry really as any discipline that uses numbers to understand our forestry resources. And so in the forestry context, that's often forest measurements, forest mensuration, growth and yield modeling, ecological modeling more generally. And I think there's a need to do this because I often get frustrated when I see new and cool techniques out there that are available to do data analysis or statistical analysis that really don't lay out the foundations before kind of diving into those things. And so I'll give one example. When I was a faculty member in my previous position, I would often see classes that were being taught by faculty, and these were new classes that were often labeled things like machine learning in the 21st century applied to agriculture and natural resources, or artificial intelligence and how to navigate uncertainties and things like that. And I always got frustrated when I saw those. I mean, first, awesome that we're teaching those classes, but I always got frustrated because we never really have covered the basics and the foundations that lead you to those upper level classes. And so I think in a lot of ways that we can benefit ourselves if we really go back to the basics and think more about what are the core skills that students need to better solve forestry problems. And so I'll touch on a couple of those. I listed out 4 of them that I'll touch on here today. And I should say that a lot of this information that I'll talk about is actually from a survey that I actually gave to my students when I used to teach a class called Natural Resources Statistics at the graduate level. And so I've surveyed those students just to ask them, okay, you've taken this course. And this course that I taught them was really an introductory class for statistics at the graduate level. And so we kind of sped through at a quicker pace as an introductory course, but we started at basically probability concepts and how that leads to hypothesis testing and analysis of variance. And then by the end, we touched on some of the more advanced regression modeling techniques like logistic regression and mixed models and even zero-inflated regression. And so with that course, after having that foundation, at the end of the class, I gave them a survey and I said, basically, what topics do you want to learn more about that could help you in your own research? And so I'll link to that survey that I shared with students and some of the results, but I'll really kind of draw a lot from that survey and what I'll talk about. And so the first thing that I think we really ought to be teaching more of in our disciplines within forestry is how to make good visualizations or good graphics. And so this is just a really essential part of what I call the data analysis workflow. And I think it's really important for you to be able to convey the work you've done to in diverse formats. And so not just to write out in text form, say you're to do a timber cruise and you have some summary statistics that you want to show, but could you also put those in a table or a figure format? And how do you actually do that? What are the skills you need, whether it be R or ggplot or some of the other statistical softwares that can help you to do that. And I think that having more skills, more expertise in how to make excellent graphics can just showcase the work that people do that much better. I always like, and I always tell people that really the great analyses start and end with visualizing the data. And so in my book, Statistics and Natural Resources, I've actually formatted the book that way. And so if you look at the first chapter is all about how to visualize data using ggplot, which is the commonly used package in R that's used to look at data. And then the very last chapter of the book is how to really think about supercharging your plots with ggplot and other things to be thinking about, like data dashboards and like Shiny applications and things like that. And so I think if we can develop the mindset in students that all the great analyses that you'll do start with graphics and end with graphics, I think we can do them a lot of good service in doing that, because we all know that, if we visualize the data first, right after you collect it, you can easily begin to see, data entry errors, other things that might be going on with the data that you might need to reconcile before you go ahead and do your analysis and then realize that you have those problems at the very end. And so I think giving students good skills in graphics and visualizations is just going to help them much more into the future. The second one that's really related to that is exploratory data analysis. I don't think we often teach that enough in some of the classes that we do. Again, I think, as I mentioned earlier, how good analyses start with a visualization, I think we should do more to be thinking about and to instilling in people that the ability to explore your data first is going to get you more acquainted with it and be able to better use it effectively into the future. And so I often, when I used to watch students that often will spend a whole entire summer or 2 summers collecting their data, the first thing they want to do is, type all the data, enter it all into Excel, and then start modeling it and start running the ANOVAs and the regressions on all the data. And I always hate when I see that. It's like it's like the same thing as if you meet someone on your first date, you want to go ahead and marry them by the end of the night. And you don't necessarily want to do that. You want to get to know each other. And so you want to get to know your data. And so I think exploratory data analysis is a big part of that. That can certainly include graphics and visualizations, but also things like summary statistics and how do we look at the distribution of the data and how do we manage the data in a good way that we can effectively summarize it in the first place. And so I think all of that is a component of exploratory data analysis that we really ought to be teaching more skills of, because all of the subsequent analyses, the modeling and the ANOVAs and the statistics, that's all going to come later. And if we have a good foundation through our early data analysis, we can then be set up well to have a good analysis into the future. Another one I want to talk about as something that I think we ought to be teaching students more of is reproducible research. And so I'm going to steal a definition. This is a great paper by Roger Peng, who kind of has looked at the trends in reproducible research that I'll share a link to. But he defines reproducible research as consisting of the following elements. A published data analysis is reproducible if the analytical data sets and the computer code used to create the data analysis are made available to others for independent study and for analysis. And so he goes on to say, he's like, well, yes, that is a very vague definition. It's, well, what do you mean by available? What do you mean by computer code? And what do you mean by a data set? But I think it's a good framework to think about how we begin to showcase the value of doing reproducible research. And so I think for many people, certainly the reproducibility aspects are that so someone else can perform the analysis. And certainly if you're in the public health sector or in medicine, and that's where Roger Peng sits, he's kind of in those fields, that idea of reproducibility is ever more important if you're working with human lives and you're dealing with people and things like hospitalizations and human deaths. It's incredibly important. I think from a forestry context, we can also do good things that fall in line with reproducible research that aren't necessarily even for other people to be concerned with. I think one of the best things about reproducibility is that you're making something reproducible for yourself, and so that your future self can rely on some of the work you did earlier. And so I think there are definitely a lot of great things that are valuable about reproducible research. in terms of being able to reproduce what you've done for yourself and for others, and particularly as we've seen so many people changing roles, both leaving companies and changing roles within a company. Institutional memory is a big thing, and so anything that's reproducible that people leave behind is just going to add more value to the company. And there are certainly great tools for doing this, and certainly there are some great tools and programs like R that can do this. There are tools like GitHub and other version control systems that we can be teaching more of that get students into the framework and in the mindset of not just one and done. Don't just do the analysis and be done with it, but to think about making it reproducible for yourself and for others in the future. And then the fourth thing I'll highlight is just the incredible value of critical thinking as it applies to solving quantitative forestry problems. And I think this really comes through with project-based learning in many ways. And so forestry, we often don't even really think about this, but in forestry, we, as a part of labs and time outside, we collect data in the field. We wrap the diameter tape around the tree. We stand away from the tree and measure its height. And so we have a good sense of what the data are because we often have some piece in collecting it, especially as students. But I think more that we can do to instill that project-based learning early on and really throughout someone's education is just going to be incredibly valuable. You only ever really learn something if you have a good idea about what it is, the population that you're studying. And so I remember when I was learning statistics and some of the examples that were used, there was one that was like from a textbook that, it was learning the statistical concepts are hard enough, but trying to understand what the examples are and what you're actually measuring makes it even difficult. And so one example was actually measuring the rise of dough as something was baking in the oven. And they were kind of measuring these different things. And I think the treatment was the different kinds of dough that were used and are they different at different temperatures. And it was just incredibly difficult to understand, okay, well, when should the dough rise and how much should the dough rise if you don't necessarily have an understanding of that. I myself, I'm not a baker. I don't know. But the ability to use data that are in the field is just incredibly important. And I think students can certainly use critical thinking skills to then apply what they've measured to their analysis of those data. And so I think giving them opportunities of that with experiential learning, but also more kind of independent project-based learning can only help that because you don't really ever learn something until you do a project from start to finish. There's a great study by the group Crowdflower that studies kind of data science roles and what data scientists spend their time on. And they estimate that about 4 hours every day is spent by data scientists just to kind of do something with the data, label it, collect it, manage it, manipulate it. And that's not ever really doing the data, the statistical summary or the data analysis. And so just to give students the idea that, through a project, applying critical thinking skills is going to be needed to have a really effective project as they encounter problems in the business world or in other applications of solving forestry problems with data. And so with that, I hope those were insightful. I'll share some links in the notes about some of these different aspects of what I think we should be teaching more of in quantitative forestry. And if you're interested in this or if you have any thoughts, I'd love to hear them. You can find my contact information at arbor-analytics.com. And I'm always happy to respond to you over email or to have a quick chat about what your thoughts are. So thanks, everyone. Thanks for listening to the Forest Analytics Landing Podcast. For more information on how data and analytics can empower your organization, visit arbor-analytics.com.